Okay, so thank you for attending today's webinar. Actually, we are already at the ended the second quarter. Is we passed over the six months from starting from the January. So this is about the fifth the webinar that I organized under the name of the AI Native Pattern Practice Academy. So it'll be the final for the first two sec quarters, and then we expect in the next quarter with the more fascinating topics. Okay, first I'll share my screen and then start. Okay, slideshow. Okay, thank you for attending today's webinar. Today's webinar topic is Agentic Legal Knowledge Management in AI-enabled patent practice. So we have two sessions. One, I will read about the general topic of today's agenda. And then Julius is a co-founder CTO of the Think Trust. He will share his insight. Actually, here is another page about the detail. So he will talk about building machines that speak pattern. So representation space as a pattern knowledge system. So both of the technical guys. So beyond that, I'm also a pattern attorney. But so most of the talk probably a little bit technical, but I want to just deliver the most key part, like avoid any technical details. If you are interested, and then I made my slide more like a detail, additional kind of like contents, so you can look at it. I already shared my presentation in chat box, so you can look at it later. Okay, so first I will start at the general overview of the today's topic, agentic legal knowledge management in AI-enabled patent practice. Okay, so check that first. Okay, so first, actually my webinar series already have about the four times of the focus on this AI-enabled patent practice in all different aspects. So if you are interested and post it in, there is a AI-enabled patent practice. If you type this name in LinkedIn, like a search, and you will find the site. And then I post all of the previous webinar recording presentation, and also there you can find out about a dozen white papers about details in this topic. Okay, so but I review for the today's topic. So AI and patent practice actually evolving. So patent practice is undergoing architecture transformation. Why? Because of AI. So AI is reshaping the overall architecture of patent practice by embedding intelligence through the entire life cycle. So AI native patent practice focus on life cycle integration. So that means to ensure that decisions made in one stage could inform downstream activities. So you are in the patent practice, you know what it means, right? Because for example, you will see the example life cycle means that they're starting from the new innovation and invention disclosure, and then patent research, and then drafting, and then filing, prosecution, OA, and granted and continuation. And after that, post-granted patent like portfolio management and licensing, monetization, and litigation, something stuff, right? So they are all integrated. And another is a workflow integration alone is no longer sufficient. So recently, for example, that I have an opportunity to work with the most comprehensive AI solution. Maybe as of today, the name was Deep IP. So I explored all their module. Actually, they have a nearly full cover of the patent life cycle, except the up to the patent portfolio management. But before that, actually, they're very comprehensive, except they are not yet about like a patent monetization, licensing, and the patent litigation. But I found that they are not actually that I just have a conversation with their technical group that they should be integrated internally so one module can be integrated to the other. So up to the point that I had joined like a webinar before. Just before this webinar, actually, they told me that they integrate internally, but not fully functionally sufficiently integrate to be, as I call like today, that fully exploit in the like agentic knowledge management. So that's the current status. And next evolution is memory-driven legal intelligence. That means that whatever you generate through this module or whatever you practice, it should be the knowledge base, and then it will be further elaborate utilizing this as a knowledge base to be in your or whatever you in the future task. For example, here that so the pattern practice span the complete innovation life cycle that I already explained, unified strategy process rather than isolated legal activities. But unfortunately, I'm not sure that the currently whether some of the big law firm or the big companies like a legal department maybe have the system. Otherwise, not fully adopted yet. And every life cycle stage generates a strategic legal intelligence, so create value organizational knowledge that should strengthen future patent matters. Okay, so and then cross-stage intelligence flow creates better decision, right? So they should be every stage of the workflow should be continuously communicate, so they connected. So continuous knowledge flow produce greater consistent and strong long-term portfolio performance. So AI native organization optimize the entire life cycle rather than individual tasks. So optimizing strategic decision quality across the complete life cycle of innovation, legal protection, and commercialization. Okay, and then so workflow automation, that means AI tools are no longer the limiting factor, mean that the limiting factor is no longer computational capability, but the architecture used to connect these capability together that I mentioned in D by P cases. And workflow output must become a reusable organizational asset. So reusing structural output enable workflow to scale while reducing repeated analytic effort is very important. And the workflow intelligence emerges through the integration, so decisions become increasingly aligned with the business strategy, competitive positioning, and long-term portfolio objectives, right? So it looks like very theoretical and very ideal, right? But uh, as AI mature, right? Because we have a lot of tools, and then current limitation is overcome in many aspects, and then if the business sectors like started to understand really this kind of like a fully like developed the pattern intelligence utilizing knowledge management and a workflow integration is really needed, and then ultimately it'll be generate the value to the company, right? It'll be adopted slowly, but I that's my hope that I start in this academy to cultivate like to the in the future pattern practice should follow these ideal cases. So scalability depends on preserving analytic continuity, so continuously retain and propagate analytic intelligence across multiple matters and organization teams. Okay, so why ANA pattern practice requires knowledge architecture? The integrated workflow still lose valuable legal reasoning if it have integrate and then practitioners utilizing integrated one, but still they are not in the fully integrated level of the legal reasoning. So reusable institutional knowledge is very important. So legal reasoning must become structural organizational memory. So capturing reasoning as a structure knowledge enable organizations to accumulate expert instead of the repeatedly reconstructing it from scratch. And then knowledge architecture enable coordinate AI reasoning, so coordinate analysis, the ground in the same origin knowledge base. Okay, so having said that, I will explain a little bit more of the what is meant by the agentic legal knowledge management. Actually, it is a little bit in a sense of the like in general overview that you understand what is meant by the agentic legal knowledge management, but actually implementation requires very different level on this technology and pattern practice. So I will just introduce just only the essential part. So what is agentic legal management framework? So agentic legal management transform legal knowledge into organizational intelligence. So continuously extracting legal concept, reasoning chains, examiner interactions, strategic decision, technical relationship, and business context from every pattern matter, and converting them into structural organizational knowledge that becomes increasingly valuable over time. This is a key part. So framework introduced persistent legal memory as a foundational architecture layer. So this is one thing that I'm also like innovator, not just a pattern practice. So I'm also like consulted or work with a very frontiers technology innovation company, and mostly my current focus is to advance kind of AI, especially agentic AI. Particularly recently, there are a lot of the like ways to the developing the new way of the AI chips that they call inference chips. So that means that the inference chip actually that the not just the passive way to act as a traditional large language model, they are the top layer to be inference engines to provide all kind of like inference at the chip level. And then the funny thing is that if you look at if you are very interested in the investment, for example, is recent stock market, you know like there are rising the start is there is a not the actually the AI chip company. You know, like the company that are the rising star is a memory device manufacturer, right? Like TSMC, Samsung, SK Hynix, Intel, AMD, that kind of company, like Broadcom, right? Broadcom is not the memory, the chip company. So, so as you said, more agentic AI is working. Create what we need is all the previous things to be as a stored as a memory bank. So as agentic AI is more popular and overspread, and that'll be the thing is actually the in the hardware, in the memory is more required. So that's the funny thing that relates this topic, right? So continuous maintain so institutional legal memory is very important. So legal reasoning developed in the previous matter to inform future work automatically. So specialized agent collaborates through spread organization knowledge. So you can think about it as a teamwork, right? So AI also can teamwork. They call multi-agentic AI system. The so-called like agent groups to working together, and each agent in the specialized function like specialties in pattern practice, something like that. So the objective is continuous organizational learning, right? So entire pattern organization evolve into continuous learning legal intelligence system. Okay. And the knowledge ingestion. So this is just explain about how actually that it enables actual implementation of this architecture, something like that. Actually, I will skim over this one very quickly because I will show the live demo. So you will look at the through the some example that you will sense about what is meant by this. So knowledge ingestion, knowledge graph organization, reasoning, and also like a reasoning engine transfer knowledge into explanatory legal intelligence, and governance ensure trustworthy AI network pattern operations. So actually, I'm very expertise in agentic AI, so I developed this framework last year, and then last year I just apply for the in general legal practice. And then this year that actually to apply to specific pattern practice area. So I already shared with you my two previous white paper about this topic. So if you're interested in technical details, and then you can look at it. And then persistent memory, and then legal memory extends beyond the conversational history, and knowledge continues to accumulate across the pattern life cycle. And organizational experts become reusable across future matters, and memory transforms isolated legal work into cumulative intelligence. So improve future decision making is a key point. And the multi-agent system. So as I mentioned, they specialize and contribute unique legal expertise. So you can train them as a specific legal expert, and shared legal memory enable coordinate reasoning, and workflow orchestration coordinate collaborate legal analysis, and organization function as an integrated legal intelligence system, right? This is very key. And then every lifecycle stage generates reusable legal knowledge, and knowledge continues flows between lifecycle stages. And then this is one actually that you can iteratively working on, and then feedback to them so they learn from the previous reasoning cycle. So you can see this in my demo. So what it means, the feedback loop continues to improve organizational reasoning, and the pattern lifecycle becomes a continuous learning computational system. Okay, so live demo. So I just prepared a very simple live demo. Actually, this is a simulate live demo. So I don't have any chance to fully implement this one. But hopefully in future, if I have a like technical partner want to implement, and I willing to collaborate to actually implement this one. So this one actually the demo simulate to realistic pattern matter from perspective of practicing pattern professionals. And then I use ChatGPT is a simple tool that serves as orchestration environment for multi-agent pattern intelligence system. And then the demonstration follows the complete reasoning process rather than only the final answer. And then demonstration illustrates practical implementation of architecture introduced in this webinar. So actually, I know about how to implement in a practical thing. So if you're interested in it, we can collaborate. And and then demo object is how agentic legal knowledge manager support the complete pattern life cycle, and demonstrate how persistent legal memory improve pattern decision making. Okay. And then demonstrating coordinate reasoning among multiple specialized agents. You can see that what kind of agent involved, and they reflect the collective expertise of the organization. So multiple team members organize and then collaborate. And then most importantly, all of this agentic AI should be oversight by some governance architecture. Usually a co-filer with a human expert is very important stage. And then transition from AI is pattern practice, AI and organizational intelligence is the proposed. Okay, so I will show the demo. So this is I just design it, so I test this, so you can feel that. You will see. Okay, so I just utilizing ChatGPT and prompt engineering to implement that I mentioned, like agentic legal knowledge management. So you can see that. So I give you that the AKLM is a patternized graph organization legal memory, retrieval augmented reasoning, and continuous organizational learning implemented. So at the initial stage, I just set the learning demo, and then it will set the enterprise system initialization, and also like agent activated. So you can see that pattern intake agent, knowledge fusion agent, multiple agent specialized in their field contribute, and executive dashboard. So demonstration roadmap. Today's demonstration consists of a coordinate stage. So new invention intake, knowledge fusion, knowledge pattern knowledge graph construction, and organizational memory retrieval. and multi-agent patentability assessment, and drafting, claim architecture, protection intelligence, portfolio storage, commercialization, continuous running. Okay, so for example, that you are the practitioner in this group, and then this knowledge management system already implemented, and then it'll give you the like chat environment that you can take your new task. So for in this case, new invention intake. So display waiting or new invention disclosure, right? So and then I give you simple one. So through the scenario that I will use one here. So, and the start scenario selected is AI-powered battery thermal management system for electric vehicles. And they give you the technical summary and then intake system, learning about extracting all the information about around this one. And then pattern intake agent working and technology ontology agent working and then CPC correction prediction and pattern intake agent generate technical summary and inventory intelligence agent to their business trade agent and governance agent for starting to operate. So initial assessment. So invention has been successfully ingested into AI native pattern practice environment. So identify the core technical innovation and classify the invention using technical ontology, practice classification, access commercial significance, validate governance and compliance. And so it'll guide you that the value of this pattern, the like initial like invention to be formed as a pattern. And then it'll be yes. The accepted in the and then it'll give you the like is a framework that's something fundamental different. Why does our audience already know about this? So the already there is a knowledge base. It try to look extract all the relevant knowledge about surrounding this new invention. So for example, like previous pattern application, issue pattern, office section, everything here. And then it tried to develop the pattern knowledge graph to utilizing this existing knowledge base for this new task and then continue. So it has an algorithm memory. So it look at all the previous record to extract all the relevant knowledge. Then go to next step, multi-agent pattern ability assessment, right? It goes through everything, right? Because what you have done, right? In the, for example, T by P module provide this one as a standalone, then you cannot integrate unless you do some extra thing. But actually, it'll be integrated with any existing tool, or you can develop your custom tool. And then it utilizing this knowledge base with respect to current tool to utilizing to to all the analysis like a patentability, prior search, and then freedom to operate, anything that expected your pattern practice. The beauty of that is it is not starting from the scratch. It will be based on all the previous knowledge. So you can have supported of the all things, the current issue from your previous experience and knowledge. And the drafting, so it'll be like a draft. There are a bunch of the I have recognized about the 50, more than 50 actually the AI tools for supporting patent practice, and then there is a more than dozen about the patent like drafting tools that I have tested some, and then I have looked at their details. But anyway, and then you can think about that after post patent like a prosecution, something that it's just follow the like a standard patent practice workflow. So it's a time I show in a consecutive way. Actually, that it is a full life cycle, maybe take at least 6 months to 1 year to multi-year. But anyway, because you have another task and then it go along through your practice. So this system is always full of tests. Okay, and then how you do in the exploit? If you have issued one and portfolio strategy, this is common practice. Okay, so it will and go on, right? So until you have a fully, and then after that, actually, you have a final review about what you have achieved, and then ROI and anything that, and then it will be this will be the retread if you have a similar case in the future. Okay, okay, I will stop here. Okay, so Julius, can you start your talk?
Yeah, sure. I'll hop over. Let me just screen share real quick. Can you hear me all right?
Yeah.
Awesome. Great. Let me just share my screen. Awesome. Just a quick introduction for those of, I guess, yeah. My name is Julius Highcutter. I am the co-founder and CTO of ThinkStruct, where we build patent intelligence at scale. Um, And today I'm going to talk about how we build machines that speak patent. And this is kind of a talk that I've given a couple times, but I kind of adjusted because Alex and I met with Alex a couple weeks ago to talk about this event. And, we were talking a lot about knowledge systems. And so I wanted to bring up this idea of representation spaces as patent knowledge systems. So as we think about building patent knowledge systems for AI native um, law firms, like looking at what specifically that looks like. I'll go more into the talk in a bit. But just to give you guys a quick overview of what I'll be talking about, I'll talk about kind of what I like to call the problem of encoding knowledge, or the problem of kind of getting one centralized source of knowledge in your system that you're building. Then I'll talk a little bit about knowledge and representation spaces, looking at representations as a way of storing that knowledge. And then I'll have a quick demo on how to learn a representation space. And then after all of that work, we'll then finally dive into patent law a little bit and figure out how do we use these to actually build AI systems in patent law. And then how do we use that to build the fundamental intelligence layer that we know and love. And so that's kind of a brief overview of what I'll be talking about today. I'll go ahead and start with the problem of knowledge encoding. And so to give kind of an example of this, I wanted to go ahead and look through what knowledge looks like in an organization, or what the knowledge flow looks like in an organization. So we have, so say this is you. And then, in a very typical workflow, to learn about other things in the world, you'll go ahead and very frequently look them up on the internet. There's, of course, other ways of learning about things, but you'll find some website and you'll learn about them. Very commonly, especially at firms, you'll see lots of people writing in Word docs reports that either are stored away on your computer or some organization-wide filing system to essentially help record that knowledge and help you remember it later. Of course, there's always communication to individuals via just speech, Slack, email, whatever it is. And then those individuals can often access the same set of documents, and so you can use these documents to transfer knowledge. And so this is kind of a very classical kind of little scenario of how knowledge is encoded in an organization. And then, so here, now we have all these AI agents. And so people are exploring ways in which they can have AI agents communicate with them. And, very frequently we're just prompting them, or, if you guys have heard about transferring markdown files or building up all these agents with markdown files, that's usually how these are built. And then, of course, we build agents that communicate with each other and then they communicate to the outside world. And so this is, there's a lot going on here in this diagram, but the point of what I wanted to share here is that there are lots of ways that knowledge is encoded through Word docs, web pages, emails, prompts, markdown files. And I'll call those rather limited forms of knowledge. They're more information than anything else. They don't really have anything intelligent behind them interpreting what's going on or being able to take initiative and perform outcomes from there. While as the information that's stored in humans and if you like AI agents as well, somehow is a lot deeper. And it's not written down in some document shape, and it has a much more impactful um, um, yeah, it has a much larger impact on what you do in your practice. And so the main point here is that it's easy to build prompts and train models off of limited forms of the data, these markdown files, documents, emails. But there's a lot of information missing, and there's a lot of knowledge missing, and that's the knowledge and the information that's actually in the humans and actually under the hood in these models. And so the question is, how do we capture and build up the full set of knowledge in an organization like this? And of course, being in patent law in a patent firm, how do you capture that and really write it down, other than just like writing down huge amounts of documents? And then the goal is, how do we transfer that knowledge to AI agents? So how can we avoid having to write up all sorts of prompts for AI agents to read? And so, as you might suspect, the fundamental way that knowledge is stored in these agents and in these AI models, and also there's been a lot of studies about how knowledge is stored in humans, is through something called a representation space. And so I'll dive a little bit of what that looks like specifically, and we can kind of get an idea of what it is. But the idea is it's not really a limited form of like, I'm going to write down in this long document all the facts that I know. Somehow it's stored a little bit better in your head. And so I'll start. A representation space is simply a mapping from raw data to structured encoding that captures essential information. That's fairly wordy. I like to think about it in the broad sense as a map. So you have your home, you have a museum that you're going to. Maybe after that you visit the market. And the idea is that you could write all down in a big Word doc or in a note, like where exactly each thing is and what you did. But in our head, we have this mental image of a map. We have this mental map of the places that we traced and where we went to. And the idea is that this mental map is chosen not arbitrarily, but chosen because it's easy to help. It's easy to memorize and learn from where you are and where you're going off of that map. It's a really nice relational kind of positional encoding that tells you, okay, I'm here, I'd like to go here. And so these kind of carefully chosen representations help learn the data. And so the idea is, if we can find a way to carefully choose a representation for whatever data we're working with, in this case, patent data, then we can really understand the data a lot better and then build knowledge systems up off of that. And so, the map example is great, but it's, it is in the end just a map, nothing too fundamental. But so I wanted to show kind of a quick demo in how information is shared in representation spaces. And so I'll build like a very, very simple representation space here. So I'll put a boy just kind of randomly on my page, and then I'll put a girl somewhere else, a little further away from the boy because they're not quite the same. And then I'll choose to plot a king kind of here closer to the boy than it is to the girl. And then if I ask what should live here, what concept should live here, maybe I'll ask if people, I don't know if anybody feels like typing into the chat, but if anybody has a guess of what might belong there in that where that question mark is. All right. I'm having trouble pulling up the chat, but I'll go ahead and give it away. It's a queen, right? And so what's really exciting is in this very simple plotting of these concepts, I now have actual information encoded. I have information of what belongs here that I've now encoded into my space. And this is a fairly limited example, but there's lots of really cool research that shows how this applies to kind of more complex models. And the core concept being that the structure of representation spaces encodes information about the task. And so the idea is that here, this is an image generation model that we sample. And on the left is a dog image that it generated. And on the right here is a cat image that it generated. And then my question is, if I move in the representation space from left to right here, so just like I moved in this previous space from the king to the queen, what comes up? What kind of images are generated? And quite unsurprisingly, it's kind of this like weird transformation from a dog to a cat, which is quite fun to look at. And the idea is that this space now has structure to it, and it has structure that both AIs and humans can reason about fairly well. So it's fairly interpretable to us. We can look at this dog and we can see it turning into a cat, which is really cool. And then, yeah, and to the AIs, this is how they kind of integrate the concept of a dog and a cat. And so these kinds of structures and representation spaces kind of encode the information about the task. And as we choose and learn careful representation spaces, we can then encode very particular information about the task. And I'll connect this back to patent law soon, I promise. But for now, there's kind of you can have fun with these images. And so, these last set of images that I said is, we just randomly sample from the space where we know there's humans, and then we get these kind of human-looking objects. And this was back in, I think this was published in like 2021 originally. So these image generation models are much worse than what we're used to seeing these days. But the idea is this is then how we can generate images. And so the idea is that, by now I've kind of shown that this is a kind of a really good way to store information in these representation spaces. But the idea is that knowledge is a little stronger than that, right? Like while information is the raw, organized facts and data, knowledge is the understanding, interpretation, and application of that information. And so what's really cool, so there's research being done kind of here right around the corner from me at MIT that shows that the representation spaces inside of large language models are very indicative of understanding and interpretation. So what we see there is not just organized forms of data, but actual linkages and plotting of things like you can see here from Manolis Kellis, like the meaning of life and artificial intelligence and how all those topics are connected to each other. That seems to, at least when we read it, either through natural language output or by looking directly into this space, actually transmit some form of knowledge. And so the idea is that these representation spaces chosen carefully are promoted essentially up from information all the way into knowledge, which is really exciting. So it means that if you carefully learn a representation space around a given task, say patent prior art searching, then the actual structure of the space implies knowledge about that task, which is really cool. So, and I'll get to that a little bit more later in a sec. But the last thing that I'll leave you with on just kind of general representation spaces and what they mean is that the complexity of the information in these representation spaces scales incredibly well with the parameter count of the model and of the space. And so, these are kind of, so for those who know Wolfram Alpha, Stephen Wolfram is a great mathematician. He did a lot of thinking about this, and he published this thing called the Rulliad, which is essentially showing that we can actually, through these representation spaces, kind of entangle all knowledge, which is really exciting. We haven't gotten there yet, but the idea is we can get there soon. And this is fundamentally what is happening inside of a language model. They're kind of learning these representations for the English language. And for or the Spanish language or whatever language they're operating over. And in it, they're kind of extracting core concepts about how our world works. And so the next, I wanted to kind of show how to learn a representation space. And so I figured by this point in the talk, I've already gotten a little bit into the weeds of it. And so instead of going through it, I thought it'd be kind of fun to do a demo. And so I will go ahead and paste the link into the chat as well. But the idea is that you can, and let me swap over how I'm sharing. Um, the idea is that this link goes to a little prompt here where you can rate essentially how related some animals are. And the idea is we're actually going to learn a structure for the representation space of animals. So I'll go ahead and put it in and I'm gonna go ahead and I admit I had some interns yesterday at our company do this demo for us. This is my first time showing it, so I'm not 100% sure that it'll work. But the idea is that kind of as this grows, we'll be able to see us learning some of these representations here. And so you see, essentially, as you vote, like how similar animals are, we start to develop a good representation of of what this looks like. So I'll just pause here for a second and um, let some submissions come in for people ranking. For those of you who need the link or the QR code, here it is again. And what's really cool is that we'll be able to create this space just off of you ranking how similar things are, and being able to teach a very, very tiny model I have in the background here that has no prior art, no prior knowledge of any of these animals. Essentially, be able to teach them to put them in a space that would make sense to us to look at. Cool. So we'll go ahead and see how things are going. And so here you see we have kind of some fun things that have happened. For example, we have house cat, cheetah, tiger, leopard have all kind of found them ways to each other. Kind of next to this is a lion, lynx, kitten. They've kind of found themselves in this bottom quadrant. We have these kind of sea animals that have found their way to each other up here in the top right. Tuna, octopus, stingray, shark, salmon. And so this is, I don't know, at least to me, this is fairly exciting. This is, again, this model has no prior knowledge of anything and just simply based off of these kind of 262 votes of similarity, then kind of shows what things look like. And you see, as people do votes, you can see the little adjustments that happen here. We also have some nice birds together, pigeon, hawk, robin, owl, which is quite exciting. Yeah. So this is a kind of a short demo, but hopefully this gives you a kind of a good idea of how these representation spaces actually learn from there. So that is a lot of jargon about representation spaces and why we care about them, how they're built, and how they get learned. But I want to touch a little bit about what the representation spaces of patent law look like. And so one really important thing, kind of as now Alex touched on at the beginning, is that patent law requires much more knowledge than just what semantically is represented in out-of-the-box models. Somehow we need to be able to, for every specific patent practice, to encode the knowledge of what that patent practice needs, from its portfolio to its to the prior art that around its documents, to its inventions, its IP strategy. Somehow that all needs to be encoded into a space. That's much more complex than just what the standard out-of-the-box model knowledge might have. And so one way to do this is, of course, you can just go ahead and upload all that via the Word docs that we kind of showed and talked about at the beginning. But again, the main theme here is that the kind of the idea of just in English, what sounds similar, or kind of in English or in kind of normal day-to-day life, what would resemble as red flags in patent law might not actually be two specific things. So this is kind of a case that I pulled where the patent on the right here, I apologize, the text's a little small, but it's about a water bottle cap. And on the left is some chromatography patent. And it turns out the patent on the right is invalidating to the patent on the left as founded by this kind of scientific plastic products via Biotage tool. But the idea is that language models would never really find this because there's no real language overlap here. Even if you asked it to dig, they're talking about fundamentally different things. It just happens to be that the kind of water bottle cap discloses enough information to cover some of the claims of this flash chromatography paper. And so the idea is that we should train a representation space that's able to capture the idea of novelty and obviousness far beyond just patents that sound similar. And so this is a big part of our research program here at ThinkStruct. And so you see on the left here, you see kind of what trainings of that representation space look like. So this is a prior art search example. This kind of little yellow dot is the patent that we're looking to invalidate. And then these green dots here are the anticipatory prior art that we'd like to find. And so, and the red are just kind of prior art that's non-anticipatory. It doesn't actually matter. We'd like to get rid of it. And this kind of dashed line is my lasso of everything that I'm catching. You can see kind of in the normal embeddings that you see in language models when we take a look at language models and take a look at what they're actually thinking about in their representation spaces. You see that there's a ton of noise. There's essentially a ton of kind of little red dots. A lot of the green dots have escaped. And so we miss a lot of prior art and we find a lot in our results that isn't actually prior art. And for anybody who's used a language model to do prior art searching, you very much can see this in day to day. And so the idea is when we start to train our own embeddings, so our own patent-aware embeddings, first of all, we get a much better capture of all the prior art. Here you see we're actually able to capture all the prior art in our little circle. And then there's a lot less noise, right? We still have some noise here in our data of non-anticipatory prior art that we maybe don't care about that's found its way in. And then the last step is you can actually, when the models are able to train on this representation space and get an understanding of claim scope, they're able to actually put a gradient into this classification boundary that makes it so we can actually just directly select out the prior art, which turns out to be hugely successful, kind of as you see here in this kind of heuristic demo. And what's really cool is in building this, you actually can look at what the models are thinking about and what the models are looking at. So this is kind of a heat chart of when we train our models, what do they look at inside of patents? And so everything that's brighter is what they're looking at more. This is on average over about 1,000 patents. And so you can see, unsurprisingly, they look at the abstracts a ton, which is this kind of these columns on the end. They look at the first, maybe not the first paragraph, but like the second and the third in the description, which makes a lot of sense. The first is often just kind of preamble, not that useful, and the second and the third is where they're kind of disclosing a lot of their a lot of the invention information, and then they'll take a look at the claims, obviously, and especially index on the first ones. And so while they're paying attention to the entire patent, like kind of a seasoned examiner, they're able to take a look and parse apart at these things, which is how we get really good understandings of claim scope. And so the idea is that you know, the technicalities here are kind of, you can bog down and look at them and stare at them forever. But the idea is that using this, you can build a representation space that has a really good understanding of novelty and obviousness, such that you're able to work with it in patent law really well. And so, and then this is just similar to how we were able to kind of way back create this kind of representation space that had a quote, really good understanding of kings and queens and boys and girls, here are cats and dogs. We've now built a representation space that has a really good understanding of patent law. And so what can you build out of this? So, you know, from here, the possibilities are endless. But one of the really powerful things is information retrieval, right? Is being able to do things like prior art searching. And so we actually have a white paper, it's cited in the bottom here, detailing about how we turn these representation spaces into really powerful information retrieval models. Now, these models look fundamentally different than your language models. They are much more accurate. They don't hallucinate. They're fundamentally not able to. And they produce search results that far exceed anything that you might be able to expect a language model to do. The idea is the language model is kind of just sitting on top of using your old English conventions onto kind of traditional databases trying to keyword search, versus this is actually indexing into the patent representations. And so we can build these state-of-the-art information retrieval models, and then from there, you know, essentially what's left to do is endless. Essentially, once you have something that can really well look into these knowledge corpuses that we've built via these architectures and able to information and retrieve information out really quickly for agents to use, then the world is your oyster, as they say. And so the last thing that I'll kind of touch on is how to build the fundamental intelligence layer of patent law, and how to build on this from here, and kind of what we're doing there as well. And so kind of in the bottom here is these patent representation spaces and these information retrieval models that we've built. And then from there, you know, it's easy to build prior art search engines, infringement search engines, claim optimizations, freedom to operate assessments, kind of these individual features that use the ability to query these super large knowledge databases that are able to be distilled not just from the patent corpus, but also able to distill information from your practice, able to distill information from your portfolio, and then you can build these really powerful tools on top. And so here below, you see kind of our kind of base model and representation space training, and then here's a lot of our features that we have listed here. And then the last step is that we've actually built MCP and API interfaces into these agentic systems. And so the idea is that now your agents have access to our prior art search and our infringement search, so that we can become the kind of foundational layer, and then we can build agents that are able to use that into, you know, really pushing towards an AI native patent practice. And so this is kind of where we are, and we're definitely going more into the MCP and API integrations. So I guess the last thing that I'll leave you with is if anybody's particularly interested in working together and kind of exploring what some of these features might look like in your patent practice. If any of our kind of our feature, of course, we sell products, so we sell these as kind of one-off products that you can buy or subscription model products. But we're really exciting is that we kind of see this as a big revolution for the patent space, and kind of the way to be a part of it is to contribute to a community. And so, while there are products that you can buy, what we're really after is building these MCP API interfaces to agentic systems, building really powerful agentic systems, and letting them loose on the world and kind of collaborating with others and building up that community. And so, yeah, of course, if you have any interest in that, you have my LinkedIn through the event and everything. But we can go over questions. I don't know what Alex wants the format for questions to be, but yeah, that's kind of my quick presentation on knowledge systems and the AI practice.
Thank you, Julius. Yeah, it's a fascinating topic. Yeah, we have about 10 minutes to have a Q&A or discussion. If you have any question that is anyone to volunteer to have share your question or your comment or insight, whatever. So basically, actually, I for the first time met with Julius. Actually, that I have 20 years in IP space and 30 years in tech. So after my PhD, so I experienced all of the emerging technology and also patent like a practice as a patent attorney, IP lawyer. Also have an opportunity to work with many solution developers. My first two like a job in IP space, actually the strategy advisor to the patent intelligence developer firm. So I know about how they internally gather the like a patent office data and then how they can represent them and then try to in the old time such tools to find out the relevance prior to patent landscape, everything. And so like I have a lot of intensive experience to developing my own identity system for all the different type of the intelligence, including every stage. And then also recently I have a fortunate experience full package of the deep IP and also have experienced many different type of the IP tools. My impression. I'm not impressed at all after 10 years. Whatever for example, there was a one thing that I have in mind that there was the solution that Innograph. Actually, it was founded by the someone actually the nothing to do with any kind of IP was he did he did his master in technology management and then he find out a new way. So I feel that at the time it looks like very new because of the I don't like impressed by their way to provide the analysis, but their way actually represent outcome. So provide a very like a visualized tool, the easy to understand tool. Otherwise, I'm not impressed at all. But anyway, 'cause it was one successful model, and I know that when I was did my this phase, actually, I fascinated by for example, at the time the name was Thomson, and then recently they divided by separate company, and then one of the companies, Clarivate, maybe know about it. And then I just fascinated by their level of the like revenue. At the time, I didn't know that this kind of like IP intelligence can provide that kind of lot of revenue. Other than I'm not ever actually I use their, for example, tool like a Dawand, and if you're the old in this industry, know, but you haven't ever uh, used that tool, Dawand. And other tools, I experienced a bunch of tools and recent tools. I'm never impressed. I feel that very useful. That's I found, right? It's very useful that if I can use, but under ROI that they provide under very high subscription fee, that unless you are the big company like in-house company or the law firm that I also know about why they choose. For example, that I have a lot of my client is a big one of the big client is Samsung Electronics in South Korea that he has more than 1,000 patent practitioners working in-house in a one unit like IP center. And then usually they don't care about what the capability, whatever that is. As a common practice, they utilize at least five tools like common, right? And then just use whatever, right? But I'm not sure because it made it difficult. But I think that what I got from my statement is because I impressed a lot from the industry innovation, not patent innovation tools, right? Why so that different, right? For example, when I come to the ChatGPT, I impressed, right? Whenever new emerging technologies coming, I impressed. Whenever new IP tools coming, I'm not impressed. Right? I found the fundamental gap as a patent practitioner for 20 years, tech guy for 30 years. Why? Why? And then I just find that the fundamental problem is how they approach these tools, right? They approach tool as a legal reasoning tool, right? Like a human expert, right? And then you can think about the human spectrum to knowledge, kind of like reasoning, is to multi-layer, right? Because from general to specific. You can think about if you use ChatGPT, the same thing, general, specific, right? So whenever I impress is, oh, why, how this guy is actually the design that general topic can apply and additionally specific topic to impress me, right? I never seen the tool in IP space, even I test, sorry for the deep IP, I never impressed them, but I found that they are very useful, right? So, so why their gap? Fundamental approach, and I found that like young genius guys like Julius, that I just with Jacob, you may be the guy actually that impressed me. Why? Because of I look at their fundamental approach. It's completely different approach, right? So maybe someone eyes are very tedious, right? It's a fundamental thing, like it's like the lecture room time, right? But we need that tool in the future. Maybe not now, because of the reason is even the patent practitioners not that sophisticated to utilizing these tools to generate value. Even I found, for example, even the Samsung, right, that the top executives completely ignore this IP practice. They just say like just to protect against our litigation. That's it, right? They don't matter as whether high quality patent, whether maybe the future, they don't care about it. Because why? Because they are not directly related to their revenue generation, right? But that tools that I hope that for 20 years I saw for that people's mind that is kind of like a money making pattern. Right? Anyway, right? But I think that there is a chicken and egg problem, but one way to actually that to provide the concept is to fundamentally different AI powered intelligence that actually that create value to the organization, and then we directly relate to revenue generation, right? That's my thing. And then I found that whole the younger generation like Julius and other guys actually the looking at the complete different view, right? And then maybe sometime, right? We have a generalist from specialist whole spectrum, right? And they impress me. Wow, finally, right? It's like reasoning like me for
Yeah.
30 years, my experience all there, right?
Hmm.
I hopefully. That's motivate actually to invite him and then to share with other people actually that not many people actually joined today for this webinar, about 210 registered, and I have a like previous webinar attended about now I count about 1,000, so I'm going to share this one. And maybe hopefully that even if I say we'll have change, I internally say to TYP, they never try to hurt because they're very busy, their own business trip or whatever. But
Right.
anyway, because I found the one. So in the future, maybe we can have another kind of like to showcase. Actually,
Sure.
we have this one, right? We have something, but we are not incremental. Whatever I found it, we are dramatically in the up to in the MIT Harvard professor like a disruptive innovation, like a disruptive innovation in patent IP intelligence, right?
Yeah.
So hopefully that we will share that. If you have anything to final comment or anything you want to share. And
Um,
I think the next time will be I hesitate to that, but actually I found at least one speaker, Julia. We
okay.
discussed about next topic will be the global readers. At least there are I found that 100 global readers that they looking at like AI native pattern practice. So I'm planning like AI native pattern practice global readers round table to gather together all the like readers to share what if the pattern practice to be an AI native, right?
Right. Yeah.
So so I will design it and then share with you, and then I'll share at the time share with this recording and presentation.
That sounds
Julia,
great. Um,
do you
I,
have any final comment? Yeah.
yeah, I just wanted to first of all, thanks so much for having me. This has been fun. It's always fun to talk about patent law and especially our insights and then connecting with the community to figure out how to turn that into actual products and actual tools that they can use. I wanted to I see there's a little bit of a discussion happening in the chat. I wanted to kind of answer some the question
Mhm.
about hallucinations and that. So I want to be very careful. I apologize if I misspoke. LLMs can certainly hallucinate, Steve. That's very correct. Hallucination is a thing that comes when you build generative models because sometimes they generate incorrect information, and very often we label that as a hallucination. And kind of as Randy points out, there are ways to alleviate these hallucination rates. You can do it with prompting. You can do it with retrieval augmented generation. There's kind of a whole field out there that tries to alleviate these hallucinations in large language model spaces. But the problem is, especially in highly specialized regions or in highly specialized tasks, it's really hard to completely get rid of them. And so, a lot of the models that we build are not large language models in the generative sense. We build information retrieval models. So these are models that instead of generating text, so you would chat with them with a chatbot, they actually all they do is they look into these representation spaces as I kind of presented them, and they pull out insights and they pull out specific elements out of that space. And so, because it's not generating anything, it's actually quite impossible for it to hallucinate. I hope that answers the question a little bit, but yeah.
Thank you. And final comment. Yeah, we will then end today. Do you have any kind of like a final
Oh,
comment? Yeah.
um, no, thank you so much for having me, and this has been fun to talk, and I hope we get to chat more about this in the future. And yeah, if anybody's, I'm always also excited to talk about these things. If anybody has any follow-up questions, you can feel free to stick after or ping me over LinkedIn or something like that, and we can keep the conversation going.
Thank you. Thank you for attending today's webinar. Yeah, I hope you have enjoy your last of the day, and then hope to see you again in my the next webinar. Okay. Thank you. Take care. Bye
Awesome.
bye.
Thank you.